Hello and welcome to Daily Shy's geometry lessons. We are out of the book. It's the 5th edition for elementary geometry for college students. If you're not in college yet, but you want to learn this, don't worry. Like, I'm just going to go slow, one day at a time, as I do in all of my other lessons. If you're getting a little bit lost early on, go and look at the previous math courses. I'm doing one on beginning algebra and intermediate algebra. If it's too slow, don't worry, I'll get to trigonometry, pre-calc, and calculus as well. So continue checking on the channel and see what content that I have developed. This stuff takes a while, especially as we get into this higher level math, because I'm going to have to draw some pictures or just prepare more things. I can't simply write things down on the fly. That being said, let's get started. I'm gonna share what I'm doing here. This book actually, it's interesting. It has this, it tells you a few of the things that you're going to be learning right away. I've been using a lot of these terms even in upper level math classes, and I kind of forgot that it's in geometry where we first started talking about this. Now, statement you should know coming into this, because we've dealt a lot with statements as well in the earlier math classes. So I'll just show you what the book says about statement. It is a set of words and symbols that collectively make a claim that can be classified as true or false. Hopefully we already kind of know what that is, but that's the formal definition of it. And so let's see if we're thinking about this correctly or not. Classify each of the following as a true statement, a false statement, or neither. So for example, 4 plus 3 equals 7. This is, the whole thing is a statement, and they want to know, is this true or false? And if you said true, then you would be correct. How about an angle has two sides? Here's another statement. We'll call this statement 1, statement 2, and angle has two sides. Is that statement true or false? Well, what is an angle? If you have a line like this, there's an angle here, but you need another angle, or you need another line, excuse me, to form the angle. So I'm going to say that that's true. How about Robert E. Lee played shortstop for the Yankees? Wow, this book, no holds bar on this book. It's not the statement I would make. Not just because it's not true, but anyway. Robert E. Lee played shortstop for the Yankees. Let's just say played baseball. Well, actually, maybe he did play baseball. Who knows? But he didn't, to be sure, he didn't play shortstop for the Yankees. So, is famous for sports, right? We'll just say false, right? So you get the idea. Like, these are statements that sometimes, like, there's a truth value associated to it. What about another math one? 7. So like sometimes you'll see something like this and you're being asked if this is even true. We know that's not true. Like, if you're on a number line and you're reading this the way that it's meant to be read, this reads 7 is less than 3. That's just not true according to how we read number lines. 7 is definitely greater than 3. So this is a false. This is another false statement. And I like that they included this one too. They give the statement, look out. Is that true or false? This is actually neither. This doesn't have any truth value associated to it. If it was look out, that thing is going to hit you, and you didn't look out and it didn't hit you, then maybe you would say false, but that's not really what it's saying. It just says look out. It's not even really a statement in the math sense because there's no true or false value associated to it. And so that's that part, right? Now, what's the next thing they want us to learn about? The next thing they want us to learn about is variable. And we know a variable is like, it's some, let's see. Well, first of all, like it's used within a statement often, and often a letter or a Greek letter, I suppose. That should probably be a capital. And it creates sort of an open statement or an open sentence because it could be classified as true or false. So creates open statements slash open sentences. Yeah, sentences, because we are in higher level math, and you will get word problems. You will get pictures and diagrams, and you will be asked these more difficult questions. It won't just be some numbers on a page. So yes, sentences as well. But like x plus 5 equals 6 is a statement, but it's an open statement because depending on what x is, this is true or false. So and x is our variable, and I think that that's the lesson here. So this is only true if x equals 1. There's no other way that this could be true if the value for x is not 1. So it's just how we treat the variable. They want us to know a little bit about negation, which is that we're going to have to learn about truth tables pretty soon, so why not do that here? Here is a truth table, and a truth table just comes with a few implications. I don't know how deep we're going to go into this. I will do a class about discrete math, which will go pretty deep into what truth tables and everything is about. But for now, let's just consider that negation, let me slide down to negation, make it clear for you. I'll try to type more than write, because if you've seen my other videos, my handwriting is not the best. A negation takes a given statement, let's call that P, and makes the opposite claim. And the reason why that's important is because let's say you have the statement 4 plus 3 equals 7. That whole thing is the statement P, for example. Okay, so let's say we have that statement down here. 4 plus 3 equals 7. Let P be the statement 4 plus 3 equals 7. So what is the negation of that? In other words, what is not P? That's what this means. This is like a negative sign, but for a statement, it just means not. This little thing means not. It's the same as saying not. And the only way that we can fully negate this is if we make this statement 4 plus 3 is not 7. And that's the negation of P. So, and, just to clarify, this means not equal to. Hopefully you know that by now. Okay, so we just need to understand our language. Math is a language as well. And so we're just learning how to speak this language together. What else are we learning here in this little introduction? Oh, we have conjunction and disjunction. So, oh no, it doesn't space down that way. I know how I can do this. So what is a conjunction? Conjunction is like adding two statements together. So maybe you have this statement, today is sunny. And then maybe you also have the statement, I'll try to keep it simple. Today is Saturday. So this is one statement. We'll call this one P. This is another statement. We'll call this one Q. And so the conjunction is basically putting these two together to be one statement together. Let me create a little more space and show you what I mean. It's saying P and Q. It's like grouping them. Not really like adding them, but making them both hold value together. And sometimes people will write it like this, although it's far more common to see it written like this. And that just means today is sunny and today is Saturday. I know, it's why not just say today is Saturday and sunny or something like this. But there's a reason for this, because when we have other statements could be expressed in numbers and such, we could actually draw some inferences based on what we call the truth table. And so without even really knowing what the statements hold, we know this rule in general. We know how this plays out. So let's say that today really is sunny. Again, a statement has a true or a false kind of connotation or implication to it. So let's say today really is sunny, right? We know that that is true. And let's also say that today really is Saturday. We look at the calendar, we look at the time, and we really know that it is Saturday. So when we look at P and Q together, then the whole thing that we are saying is true. That hopefully makes sense to you. Let's say that today really is sunny, but it's a winter break and we've forgotten our sense of time. It's not really Saturday, for example. So like this is going to be false. Let's say it's some other day of the week. Then we know that the statement P and Q, even though the P part is true, the whole thing actually ends up being false because one of them is false. Likewise, if it's not really sunny, whoops, that should be a false. If it's not really sunny, but it really is Saturday, then the whole statement P and Q is false. And of course, if they're both false, let's say it's really cloudy and it's Monday, then it's not going to be true to say that today is sunny and today is Saturday. So that's the truth table for this thing. And all we are using is this operator called a conjunction. It's a little caret. It means and. Okay, what about a disjunction? You probably have an idea about it. I shouldn't say adding two statements. It's like considering two statements together, or anding, anding two statements. The disjunction is taking the either or. So this is or. This is looking at whether or not looking at whether two statements, when put next to each other, or evaluates to be true. So I'm going to use my same example above, but just so that we're clear, disjunction is P or Q, often written like P with an upside down caret, Q. And we'll do the same exercise just to give you an intuition about how this works. Again, we'll use the same examples for P and Q as above. And we want to know P, Q, P or Q. And we're going to fill the P's and Q's out the same way. Don't worry, we'll talk through each one of them. These kind of have a pattern, by the way. I'm true, true, false, false, true, false, true, false. This is like every combination of P and Q together. So that's why I do it in this kind of combination. So let's say it is true that today is sunny and it is true that today is Saturday. Is it true that P or Q is true? Yeah, it is. They're both true. So it's true that one of them is true. All we need to know is that one of these is true with the disjunction. Is it, let's say that today is sunny, but it's not really Saturday. Is it true that it is either sunny or is it either sunny or Saturday? One of those has to be true for this disjunction to give us a truth value. And so again, that's a true statement, because if it is sunny, but it's not really Saturday, it's like half of it is still true. It really is sunny. Or someone could ask you the question, is today Saturday or is it sunny today? And if it is Saturday, you could say, yes, it is Saturday. You're not really commenting on the sunny part because it turns out that it's not really sunny. So that's why this also gives a true statement. And finally, if they're both false, they're just false. And that is the disjunction. So we've learned a lot of different things. We've learned about statements with truth values. We've learned about conjunction, disjunction, as well as negation. And I guess we're going to pause it here because we're going to get into some more complicated expressions coming up.